You're never too old or never too experienced to learn something new. Believe that you have everything already as your Brahmastra in your will to be able to achieve your success. The only formula here is your persistent practice will lead you far ahead from where you are. Listen, ladies and gentlemen, and today's topic is integration using residues. And this is the integration of the type integral minus infinity to plus infinity e power imx f of x into dx. Now in this video I am going to show by method of contour integration that integral 0 to infinity cos mx by a square plus x square whole square dx is equal to pi by 4a cube into 1 plus ma into e power minus ma, where a is a positive term. So a is a positive term. As this is an essay question, damn sure question, please do follow this video until the end so that you will get a clear clarity. So here is the solution. So first of all, we have to consider the integral as it is in terms of x. So I am transforming this in terms of a variable z. So integral f of z dz can be written as cos of mz by a square plus z square whole square into dz. Now here is the c. C is nothing but the contour. So I am taking a contour consisting of a semicircle CR of radius r and the bounding diameter minus r and plus r. See here, this is the bounding diameter of a semicircle. So this is the semicircle and this is the bounding diameter from minus r to plus r, and with 0 as a radius, so 0 as the center and r as the radius. So this contour consists of two integral parts. The first one is the real axis from minus r to plus r, and next one is the boundary line here for the semicircle with center 0 on the radius r. So here the contour C is split into two parts from minus r to plus r f of x dx, as it is the real axis, plus integral CR f of z into dz. So we have to find out both the values and we have to substitute so that we'll be getting the total integral value. As you know that e power I theta is nothing but cos theta plus I sin theta. Here e power I mz I am taking as in place of theta we have mz. Therefore cos theta plus I sin theta. So this will be cos mz plus I sin mz. So here in this question, what is the question here? This is cos mz by a square plus z square whole square. So have transformed in terms of z. So therefore in place of cos mz, what I can write? The real part of e power, the real part of e power I mz dz by a square plus z square whole square. Clear? So I got f of z value as e power I mz by a square plus z square whole square. So I have to use the residue theorem. So in order to use the residue theorem, what we have to do? So we have to find out the poles. For finding the poles, as usual, that we have to equate the denominator to 0. So what is the denominator here? The denominator is nothing but a square plus z square whole square is equal to 0. So if I send square to the other side, it will become 0. That is a square plus z square is equal to 0. Z square is equal to, this is minus a square. Z is equal to root over, this is minus a square. Z is equal to plus or minus ai. Clear? So we got two poles. So here Z is equal to plus or minus ai are two poles of order 2. So this is of order 2 as they are for twice. See here, this is 2 here. So for twice, z is equal to plus ai and minus ai are the two poles of order 2. Now we have to check whether these poles are within or on or inside or outside the given contour. So this is the contour from the real axis, bounding diameter as minus r and plus r, and this is of center 0 and radius r. So this is the CR, that is mod z is equal to r. Clear? So this is x-axis and this is y-axis, this is 0. So the journey here is from the real axis minus r to plus r, and through this the bounding line, that is CR, that is mod z is equal to r. So in between there will be, see here, so this is plus ai. So the plus ai lies within this contour and minus ai lies outside the contour. It is very clear that to everyone that plus ai is inside the contour and minus ai is outside the contour. So this is the contour region. So in this plus AI is inside and this minus AI is outside. So for within, so interior pole, we have to find the residue. So how to find the residue for this? So for finding the residue, see here, the residue of f of z for the interior pole z is equal to z naught is equal to, as it is of order 2, here is the formula, that is limit z tends to z naught. This is d by dz power, this is m minus 1. Here, this is 1 by m minus 1 factorial into, this is z minus z naught power m into f of z. So this is the formula. So here it is very clear that m is nothing but the order value. So m, the order is equal to 2 and the z naught is the interior pole AI. Now if I substitute the same thing here, so this will be residue of f of z. This is residue of f of z at point z is equal to plus ai is equal to 1 by m minus 1, that is 2 minus 1 factorial into limit z tends to z naught. Z naught is nothing but ai, and this is d by dz terms of m minus 1. So this will be 2 minus 1 and this is z minus z naught is ai power square into f of z. So what is our f of z value? F of z value is e power imx. So this is e power imz by a square plus z square whole square. So this will be a square plus this is z square whole square. Clear? And now we have to solve this one. So for this, 2 minus 1 factorial is again 1 factorial. This value is limit z tends to ai. So this is d by dz of. So this can be written as z minus a whole square e power imz by. So this is nothing but z plus ai into, this is z minus ai whole square. So this is whole square. Now I can cancel this one. So this will be residue of f of z at point z is equal to ai is nothing but, this is limit z tends to ai. This is d by dz terms of, this is z minus ai whole square e power imz by. So this is nothing but z plus ai whole square into z minus ai whole square. Clear? Now I can cancel these two, and after cancelling I have to make a derivative for one time, and again I have to substitute in place of z as ai. Clear? So this will be limit z tends to ai. This is d by dz terms of, this is e power imz by, this is z plus ai whole square. So this is of the rule u by v rule. So this is u and this is v. The numerator is u and the denominator is v. So the derivative of u by v is nothing but, this is v square v u dash minus u v dash. Clear? And therefore if I apply this formula, this will be limit z tends to ai. This is v square, that is z plus ai whole square, and this is again z plus ai square, and the derivative for this is e power imz. For z is equal 1, so I am writing im minus, so again I have to leave u here. So this is u e power imz, and the derivative for this is 2 times of z plus ai. Clear? And here this will be limit z tends to ai. So if I take z plus ai common from this, so from these two terms, here is one z plus ai and here is z plus ai. So if I take common, what remains here? This is z plus ai for one time. This is e power imz. This is im minus 2 times of e power imz by, this value is z plus ai power 4. Power 4. So if I cancel for one time, this will be for cube times. And therefore, this is limit z tends to ai. So this is z plus ai into e power imz into im minus 2 times of e power imz by, this is z plus ai whole cube. Clear? And now in place of z, what I have to substitute? ai. So this will be ai plus ai into e power. im in place of z. If I keep ai, this is im minus 2 times of e power im into ai by, this is ai plus ai, this value is whole cube. So this is going to become 2ai e power I square value here, already it's known, that is wherever you find I square, so please write minus 1. So if I keep I square as minus 1, this will be minus ma, this is im minus 2 times of again I square, that is e power minus ma by, see here, that is 2ai whole cube. So here I square, so this is I, see clearly, this one is I and this one is I square value will be minus 1 again. So this can be written as minus 2a I square, this is minus, and e power minus ma, and here what remains here, m left, minus 2 times of e power minus ma by, this is 2ai whole cube. And see, the next step will be, this value is minus 2am e power minus ma minus 2 times of e power minus ma by, this is 2ai, this value is whole cube, and this is going to become, that is 2am e power minus ma minus 2 times of e power minus ma by, 2 cube is 8, this is a cube, I cube value is I square minus 1 and 1 I remains. So here I can take minus 2 e power minus ma, I can take. So what remains here? So clearly here ma is left over and here 1 is left over. So here this value is going to become ma plus 1. So this will be minus 8 a cube into I. So now I can cancel these two for 4 times, and what remains here? So this is nothing but the residue of f of z for the interior port z is equal to plus ai is nothing but e power minus ma into, this is ma plus 1 by 4, this is a cube into I. Now after finding the residue for the interior pole z is equal to ai, so this is the value to be remembered, and now we have to apply the residue theorem. So the residue theorem statement states that, what does this residue theorem states? According to our residue theorem, so it is very clear that integral c f of z dz value is equal to, this is 2 pi I times of sum of the residues, at interior poles, sum of the residues at the interior poles. So what are the interior poles here? So this is integral c f of z. So this is f of z into dz value is equal to, this is 2 pi I into, the interior pole here is e power minus ma into ma plus 1 by, this is 4 a cube into I. So if I cancel I for one time, 2 for 2 times, so this will be pi by 2a cube, pi by 2a cube e power minus ma into, this is ma plus 1. So this is integral c f of z into dz. And now what we have to do? So what is this c here? C is nothing but the contour, and now integral c. So clearly integral c, so this is integral c f of z dz value is nothing but, this is pi by 2a cube e power minus ma into, this is ma plus 1. Clear? So what is this contour c? So c is nothing but a contour consisting of, C is the contour. It is very clear as a bounding line minus R to plus R, and this is a semicircle 0 and this is capital R. So the journey travels like this. So starting minus R to plus R. So this is x-axis and this is y-axis. Now the total contour can be written as, so minus R to plus R. So this will be minus R to plus R, the real axis f of x. So this will be f of x dx plus, this is, the next thing is the boundary line CR. So which is f of z into dz is equal to, this value is pi by 2a cube e power minus ma into this is ma plus 1. Clear? So what is our f of x? So f of x value I'm showing. So this is our f of x value. So I'm writing this as integral minus r to plus r. So f of x can be written as e power imx by a square plus x square whole square. This is a square plus x square whole square plus this is integral CR. This is f of z into dz is equal to, this is pi by 2a cube e power minus ma into this is ma plus 1. Clear? Now as r tends to infinity, what happens? As I am tending r to infinity, so this will become, see clearly, this will become, this is minus infinity to plus infinity e power imx by this value is a square plus x square whole square dx plus this is a CR f of z into dz. Value is clearly as pi by 2a cube into e power minus ma into this is ma plus 1. So this is equation number 1. Now I need to calculate this CR f of z dz. So the second integral here will be very clear as integral CR f of z into dz value. So this is a CR. So what will be f of z? See here, in terms of z I'm writing that is imz by this is a square plus z square whole square into dz. So here is a technique that, so we have to take z value as, see, z is equal to r into e power I theta, and therefore if I take modulus, so this will be mod r into mod e power I theta, as it is very clear that mod z value is equal to r. So this is cos theta plus I sin theta, and clearly mod z value is equal to r times of root over this is cos square theta plus sin square theta, which is equal to 1. So mod z value is equal to r. And next one, z value I'm taking, that is r into e power I theta. So if I take a derivative, this is r into, for e power I theta, this is e power I theta, I into t theta. If I take modulus for each and every term here, so this is e power I theta, this is I, and this is for d theta. Clear? Then this value will be, dz value will be, so this will be, what remains here? So this is r. E power I theta is clearly as 1, and I can be written as 0 plus 1 into I. So if I take modulus, this will be 0 plus 1, which is equal to 1, and this is d theta. So dz is equal to d theta. So after getting this r into d theta, sorry, so after substituting everything here in this, so this will be modulus of e power iz by this value is a square plus z square into mod dz. So everything I'm taking. So here cos mz plus I sin mz. So this is root over 1. So this value is 1. So in place of z I'm writing r, that is a square plus r square whole square. Here there is a square here. In place of dz as r into this is d theta. So here this value will be r d theta by this is r square minus a square whole square. So this is r. So if I take r square common, this will be r power 4 1 minus a square by r square into d theta. So if I cancel, so this will be for 3 times as r tends to infinity. So here 1 by infinity. So clearly this value is 0. Therefore integral CR f of z dz value is equal to 0. So integral CR f of z value is equal to 0. After this substitution, r is equal to e power I theta. So there is no need to write all this. For your understanding, for your vivid clarity, I have shown this. And now I am substituting here in this. So here it is very clear that if I substitute z is equal to r into e power I theta, this value is equal to 0. So clearly this will be minus infinity to plus infinity. So this can be written as cos mx plus I sin mx by this is a square plus x square whole square into dx value is nothing but pi by 2a cube into e power minus ma into this is ma plus 1. And now So if I split this in real and imaginary parts, that is cos mx by, this is a square plus x square whole square dx plus I times of, this is minus infinity to plus infinity, sine times of mx by a square plus x square whole square dx is equal to. So here this is pi by 2a e power minus ma into, this is ma plus 1 plus I times of 0. Now I'm equating, so now equating the real parts on both sides. Equating the real parts on both sides. So this is the real part and this is the real part. So if I equate those two, then this will be minus infinity to plus infinity. This value is cos mx by, this is a square plus x square whole square dx is equal to, this value is pi by 2a e power minus ma into, this is ma plus 1. Clear? Now see here, there is a logic here. So this is 0 and this value is infinity and this is minus infinity. The distance from 0 to infinity is same as the distance from 0 to minus infinity. As calculating from minus infinity to plus infinity, it is equal that if I calculate twice from 0 to infinity, that is cos mx by, this is a square plus x square whole square dx is equal to, this is pi by 2a into e power minus ma into ma plus 1. So if I send this 2 to other side, see clearly what happens here. Therefore, integral 0 to infinity, this is cos mx by a square plus x square whole square dx value will be pi by 4a times of e power minus ma into, this is ma plus 1. So this is how we have to solve, and this is what it is asked in the question. To show that, I am showing you the question. See here, there is a cube missing here. So here there is a cube. I'm writing cube here. Clearly there is a cube here. So this is what it is asked to show, that is pi by 4a cube 1 plus ma into e power minus ma. So this is pi by 4a cube ma plus 1. So this is 1 plus ma or ma plus 1 e power minus ma. So this is how we have got this answer. Back to the beginning, I'll explain you once again. It is asked to show that using method of integration, integral 0 to infinity cos mx by a square plus x square whole square dx is this one. So first of all, I have taken in terms of z, and c is the contour, as this is the contour, and we have to split in two parts, that is minus r to plus r, and next one is the bounding line of the semisphere, that is cr f of z into dz. As you know that, as the question is in terms of cos mx, so I am transforming this cos mx as a real part of e power I m z. So after that, we have to apply Cauchy's residue theorem. So for that, f of z is this one. So for finding the poles, we have to equate the denominator to 0. So these are the two poles of order 2. So we have to check whether they are inside or outside or within or on the given contour. So ai is within the contour. Therefore, for that we are finding the residue at point z is equal to ai. So this is the formula. In this formula, the order value is 2 and the pole value is, interior pole value is ai. So after substituting each and every term, and after solving, and after using u by v rule, and after deriving, so and substituting I square is equal to ai, so we got the residue value as this, as e power minus ma into 1 plus ma by 4a cube I. So this is the residue value, and after that we have to apply the residue theorem, and this is the residue theorem, that is 2 pi I into residue value. So after solving, so we got the final value, the integral value is this one. As this contour is of two parts, that is along with minus r to plus r f of x ds, and along with the semicircle, that is f of z into dz. So we have to find these two values. As r tends to infinity, as r tends to infinity, I'm changing r to infinity, and this value have shown you given you a clear clarity that after keeping z is equal to r into e power I theta, this value is 0, and therefore e power imx can be written as cos theta plus I sin theta. Here that this is real and this is imaginary part, and after equating the real parts we got this value. So this is the calculation from minus infinity to plus infinity is equals twice of 0 to infinity, and I'm sending 2 to other side, and this is the final answer. Hope it is very helpful for your preparation, as this is a damn sure question. Please do follow, subscribe to this channel, and stay connected, and then I'll be uploading so many videos relating to this series, and these videos will be very immensely helpful for your preparation. Please pass it on to your friends, siblings, and whomever you like the most. And thank you so much.